Next, I would like to introduce Solara's Director and Business Development Manager, Marino, who will present a versatile technology for leak detection, third-party interference, and integrity assessment applications, Vibroacoustic. This is the very first event where Solaris is publishing the capability of their system to detect not just leaks, but also third-party impact events, with a specific focus on illegal tapping issues. Marco's presentation has been pre-recorded, but he will join us for the Q&A at the end. So let's go ahead and roll Marco's presentation, please.
Good afternoon, ladies and gentlemen, or good morning, depending on the time zone where we are following this virtual pipeline summit. My name is Marino. I'm Solaris CEO, and today I will talk about this technology from ENI, which is called ENI Vibroacoustic Pipeline Monitoring System. VPS is a technology patented and developed by ENI over many years, and Solaris is an Italian joint venture between two Italian companies, Solgeo and Aresis, which is the supplier and official licensee of the technology since a couple of years. Actually, the technology is used for real-time integrity monitoring of oil and gas pipelines in different scenarios. Of course, it's non-invasive, cost-effective, ideal for retrofitting existing pipelines. On the screen, you can see an actual example of a real EVPMS sensor mounted on a pipeline. It uses existing derivation. In this case, you can see a bypass. It can monitor hundreds of kilometers with very few sensors against intrusions, spillages, impacts beyond just detection. Is currently the correct definition would be a family of technologies for integrity monitoring for many applications. A quick overview of our numbers and features. Today we serve more than 1,400 kilometers of pipelines all over the world, mainly in Italy, where we protect about the 100% of the finished product network in the country. We are able to detect impacts and precursor events before they turn into leaks. We are even able to detect manual digging activities with what we call LD plus TPI version. We have a patented noise removal technology ensuring best-in-class detection performance. It's cost-effective since you need very few sensors even to cover very long distances. Is resilient to sabotage attempts because the system is able to reconfigure itself on the fly if anything happens. And the fault alarm rate is exceptionally low. We're talking about less than one false alarm per year over a typical pipeline of 100 kilometers. We work with pretty much any diameter and any typical pressure on any fluid or gas as long as it is in single phase. The distance between stations will depend on the required performance level and the specifications of the pipeline. It can be up to 50 kilometers in selected cases. We support multi-product batches, full integration with existing equipment. Both pumping and seal states are monitored, and we have no limitation on the minimum detected leak quantity. The precision is under 25 meters, but in some cases, we reached also less than 1 meter accuracy. Our current systems spans from all over the world, basically with a very good importance in Europe, especially Italy, but also in Nigeria, where we protect many Nigerian regions, and South America. And our experience covers many kinds of pipelines, both buried, unburied, onshore or offshore, both crude and refined products, and even injection water pipelines. The principle is at the same time simple, but also complex in its implementation. It is based on a multi-point network of vibroacoustic sensors installed on the pipeline. The relative distance is variable, usually is tens of kilometers. Whenever anything happens, acoustic and elastic waves are generated from the source location and will travel at the speed of sound in both directions. They will be recorded by our sensors, and a central processing unit will give the alarm, of course. We are able to detect, locate, and classify, of course, the triggering event. A few more words about exactly what vibroacoustics is. It's a combination between sound, pressure, and macro vibrations used together and at the same time to detect a wide variety of phenomena. On the screen, you can see an artistic installation, actually a permanent one. You can visit in Milan, Italy, and it's based on the propagation of sound inside pipes. Basically, vibroacoustics uses, first of all, pressure waves, which are already widely used in the industry to detect leakage in many conditions. Pressure-based data will allow both detection and precise localization. But the vibrational component is always still present, particularly on the pipeline shell, in which it travels at the speed of sound for many kilometers, but it's very, very hard to detect. In fact, its detection requires very sensitive equipment and techniques, which we actually use. Pipes are, of course, a natural waveguide for sound transmission. That's why I call this slide the role of sound, because it's very, very important. It can detect many phenomena which are not detectable by simple pressure-based detectors. Of course, these are the three technologies which are most important for the vibroacoustics technology family, but we can also integrate with classical, let's say, flow-based techniques like ERTTM or mass balance-based techniques and NPV techniques, negative pressure wave. Actually, we serve EVPMS in two flavors. The first one is called EVPMS LD, which stands for leak and impact detection. It can detect leaks, impacts, and even some precursor events, which in our interpretation are the events which happen typically before the illegal tapping takes place. We're talking about preparation activities. Typical distance between sensors is from 15 to 30 kilometers in fluids or from 5 to 10 kilometers in gas. But we can go up to 50 kilometers in selected scenarios, like, for example, offshore installations. The system can perform also many other things like peak tracking, asset integrity, failure detection, and much more, which I will tell you about in a few moments. Then we have the LD plus TPI, third-party interference system. It includes all the characteristics of the previous system, but also it is able to detect manual digging or construction activities. In this case, the distance between stations is about 5 kilometers. The two systems can live on the same pipeline, raising distinct alarms so the pipeline operator can cope with all the differences between alarms and can decide how and when to intervene. And the LD system can be upgraded anytime and even partially to the EVPMS LD plus TPI. We wanted to show you the typical timeline of illegal tapping events on a pipeline. It's not a universal rule, but typically you have to approach the pipeline. So you have to approach typically the right of way of the pipeline. Then you start digging. You can dig a tunnel, you can dig directly on top of the pipeline. Sometimes you do not need to dig, of course. Then you have to prepare the tapping and then you can leak the product. With the leak detection technology, we intervene here from the tapping preparation, so you still have some prevention, and of course, to the leakage, when the leakage takes place, is the standard way of functioning of any leak detection system. But then the TPI detection technology can detect also digging activities, which is very important. This is an example of the typical activities detected. These are real activities which we performed on the pipeline to detect, to calibrate, to stress test the system, and so on. So we have manual digging, typically with shovel and pickaxe on top or nearby the pipeline. Hammer strikes on the pipeline shell, which is able to be detected, of course. And this is an example of the calibration methods we use, which involve specific devices which impress, let's say, a definite amount of energy on the ground and do not require invasive calibration methods, are very easy to use. About false alarms, this is like the top frequently asked question for systems like this. How can they be so exceptionally low? Because of physics. There is an exponential relationship, almost exponential relationship between the distance to the fluid and the transfer quantity of energy, which gets transferred from the source, which is the digging people on top of the pipeline, to the fluid itself. Because the key concept of vibroacoustics is that most of the energy will travel on the shell and, even more importantly, on the fluid itself. The frequency of the signal is completely different, so we are able to discriminate with very simple analysis, but going with more complex analysis, the signature is very, very different with respect to any, let's say, events caused by trains, car, or anything passing by. That's why we have such a low false alarm rate. The system requirements are very easy to met. We need power. It can be with solar panels, direct, any kind of power source is good. We also have a portable version of the system which can run for days on battery, is typically used for demonstrations. And the power consumption is very, very low. We're talking about less than 20 watts. Then we need communications with the central server, very low bandwidth consumption, about 20 kilobits per second, and the pipeline must be filled with fluid or gas for the system to work, at least 1 bar. Of course, all sensors are ATEX certified. There are many more EVPMS applications. As I was anticipating at the beginning of the presentation, the very same system is able to perform real-time peak tracking, analysis after a successful pigging campaigns. For example, we can tell you if the pig went out of the pipeline and is broken, we can tell you where it hit the pipeline with a precision of 1 meter. We can perform what we call failure detection campaigns. We can assess the quality of the sealing of inline valves, and so on, all with the vibroacoustic technology. Just some details. For example, these are example of impacts on the pipeline. You have 1 strike, 2 strikes, 3 strikes on the pipeline shell. This is a real test performed on the pipeline. We are talking about very small hammering impacts, very hard to see with other technologies. This is an example of pig tracking. The pig itself will generate sound, so the system can be used actually to track the pig in real time, even for temporary installations, but it can even be tracked if the pig is stuck and you want to use EVPMS afterwards, because we are even able to detect these very small acoustic reflections made from the pig stuck in the pipeline. Another topic is valve status assessment. For example, we are able to tell if a valve under testing is properly closing or not, if it is leaking product. All this by analyzing the ratio between an energy source, which can be done by handling a valve, and the transmitted and the reflected signal. Failure detection is another technique that we use with the very same vibroacoustic technology to detect and localize very small holes, typically made by corrosion. In this case, the pipeline you typically know already that there is a hole, but you are not able to detect where. So we assist in hydraulic or pneumatic tests, and we are able to detect a very, very small signal coming from a tiny little pinhole corrosion point. Last but not least, we are able to detect earthquakes. Italy is a country where earthquakes are very much present. And basically, since we have many systems already operational in Italy, we are able to detect frequently earthquakes. This is an example recorded by an EVPMS system located in northern Italy, which detected an earthquake located in Albania. So more than 1,000 kilometers away from the epicenter of the earthquake. It will not raise an alarm unless you want to do so, because we are able to actually distinguish the clear signature of an earthquake with respect to other events. And we are even able to assess the integrity of the pipeline after a major earthquake takes place. This one is a very general and absolutely non-exhaustive technologies comparison between EVPMS and other systems, like those systems based on flow variations modeling, like mass balance on ERTTM, those based on negative pressure wave technologies, and those based on optical fibers. And as you can see, even EVPMS has unique properties with respect to other technologies because it is not flow or product based, but it relies on the effects of interactions with the product detected by the three technologies behind EVPMS. Basically, it has a few points in common with the optical fiber, especially regarding response time and the location accuracy, which is very, very good on both technologies. It makes a good technology for prevention, not just for intervention, because it can detect no leak events. One major difference with respect to optical fiber is that EVPMS does not require optical fiber laying. This is maybe the most important point to notice about EVPMS. It can discriminate clearly what is leak to what is non-leak, and the minimum detectable leak quantity is almost zero. We are talking about fraction of liters. And as far as we currently know, it is the only detection capable of performing tasks like peak tracking, failure detection, quality assessment, and all that you saw in this presentation. And this makes all for today. If you have more questions, feel free to visit us or write me directly to know a little more about the system. And now it's time to thank you and to let some questions come in, if any.
And now we welcome Marco for the live event. Hi, Marco. How are you?
Hi, Danny. Fine.
Good. Thank you very much for the introduction to EVPMS, and also a great reason to visit Milan. I need to put that on my list for when travel opens back up.
You're welcome.
I had a question to begin with, Marco. Can you walk us through the mechanism whereby the pipeline operator is notified if an event happens? Is there an app on their phone, or does it go to the SCADA control room?
Well, actually, it's an operator's choice. Typically, we provide both, let's say, hardwired alarms like SCADA, DCS systems, or automated alarm system chosen by the clients, or it can be on an app. We have, of course, a mobile version working on any kind of mobile, from smartphones to tablets and so on, or it can be typically in the control room. Our interface is web-based. It means that the customer can choose according to the permissions that they want to set to where and when to receive the alarm. Of course, we have even email and SMS. So one important thing is not to miss an alarm, and we are sure to give multi-channel also for alarm broadcasting.
Great, thank you. William Brown has written, he was interested in the statements about pig tracking and locating. He says, does the system work with cleaning pigs as well as smart ILI pigs? Will it work with foam pigs and urethane disc pigs?
Yes, it works in both cases. The most interesting cases we studied in which we made the system work was actually with cleaning pigs, because it is more likely that they get stuck somewhere. And this is a very important feature of the system. Also, if it is too late, you can call us after the pig gets stuck, and the system is able to locate the pig up, even if the system was not installed, just by reflections, acoustic reflections on the pigs. And we are able to be very precise. We had some experience also with smart pigs. Every kind of pig makes noise. What makes the difference in the performance level is what moves the pig. If the pig is moved by nitrogen, the location accuracy would be in the order of tens of meters. If the pig is moved by a liquid, water or anything else, or the final product, the localization will be very, very precise, about 1 meter.
Perfect, thank you. A question from Nikolaos Salmatanis is, how does EVPMS handle column separation? How many bends and turns? And offshore pipelines?
It's not a problem. Actually, some specific bands can, let's say, reflect sounds or micro vibrations in different ways, but it's all compensated in calibration. So far, we work with a lot of bands, or for example, river crossings where there are many bands, or underwater installation. It's not a problem at the frequencies we work on.
Thank you. One final question, Marco. This one's anonymous. How long do you need to install the sensors?
Okay, I don't get if it is how much time I need to install the sensors, or how long does the system. The system is a permanent one, so you install the system and you are always protected. But we also offer, let's say, temporary installations. The system can be installed within hours, literally. We performed some demonstration campaigns on the other side of the world with respect to our original country within 1 day. So in less than half an hour, we were able to install a single sensor. In a couple of hours, we installed the minimum set of stations to perform a demonstration.
Fantastic. Excellent, Marco. Well, thank you again for the presentation. Nice to see you.
Thank you. Thank you.